Introduction to the Internet of Things এর দ্বিতীয় চ্যাপ্টার Everything Becomes Programmable. Introduction, welcome. So everything becomes programmable. Then apply basic programming to support Internet of Things. Basic programming concept. Follow the flowchart. So অবশ্যই আমরা জানি চিত্রভিত্তিক রূপকে flowchart বলে. So the sensor is the sensor checking for an open or a closed door. How frequently is the sensor checked? Will the alarm sound if the door is open for 5 seconds? Will the alarm sound if the door is open for 10 seconds? Will the alarm sound if the door is open for 5 seconds? Shoot for 5 seconds, then respond for 5 seconds. So অবশ্যই চিত্রের মাধ্যমে আমাদের এটা বোঝানো হয়েছে। সো এটা এভাবে আমরা চেক করতে পারি। তো সবগুলোই আগে আমাদের ফ্লো চার্টটা বুঝতে হবে, দেন আমাদের এভাবে অপশন থাকলে আমাদের কাজ করতে হবে। দেন আমরা যাব প্রোগ্রামিং বেসিক প্রোগ্রামিং ইউজিং ব্লকলি ফ্লো চার্ট। সো ফ্লো চার্ট সম্পর্কে আমাদের একটু বিস্তারিত জানতে হবে। ফ্লো চার্টটা একটু পড়ে নিব।
Flowcharts are used in many industries including engineering, physical sciences, and computer programming where a complete understanding of processes or workflows is required. Flowcharts are diagrams that are used to represent these processes or workflows. Flowcharts illustrate how a process should work. Flowcharts should not require complex, industry-specific terminology or symbols. A flowchart should be easy to understand without having to be an expert in the chosen field. Flowcharts should show input states, any decisions made, and the results of those decisions. It is important to show the steps that should be taken when the result of a decision is either yes or no. It is common for programmers to create a first draft of a program in no specific programming language. These language-independent programs are focused on the logic rather than in the syntax and are often called algorithms. A flowchart is a common way to represent an algorithm. An example of a flowchart is shown in the figure.
System, software, application software and computer languages.
System software, application software, and computer languages. There are two common types of computer software: system software and application software. Application software programs are created to accomplish a certain task or collection of tasks. For example, Cisco Packet Tracer is a network simulation program that allows users to model complex networks and ask what-if questions about network behavior. System software works between the computer hardware and the application program. It is the system software that controls the computer hardware and allows the application programs to function. Common examples of system software include Linux, Apple OS X, and Microsoft Windows. Both system software and application software are created using a programming language. A programming language is a formal language designed to create programs that communicate instructions to computer hardware. These programs implement algorithms which are self-contained, step-by-step sets of operations to be performed. Some computer languages compile their programs into a set of machine language instructions. C++ is an example of a compiled computer language. Others interpret these instructions directly without first compiling them into machine language. Python is an example of an interpreted programming language. An example of Python code is shown in the figure. When the programming language is determined and the process is diagrammed in a flowchart, program creation can begin. Most computer languages use similar program structures.
Programming variable.
Programming variables. Programming languages utilize variables as dynamic buckets to hold phrases, numbers, or other important information that can be used in coding. Instead of repeating specific values in numerous places throughout the code, a variable can be used. Variables can hold the result of a calculation, the result of a database query, or some other value. This means that the same code will function using different pieces of data without having to be rewritten. For instance, x plus y equals z is an example of a programming expression. In this expression, x, y and z are variables which can represent characters, character strings, numeric values or memory addresses. A variable can refer to a value. For instance, the expression a equals 10 associates the value 10 to variable a. A variable can also represent a memory location. The expression a equals 10 represents that the value 10 is stored in some location of the computer memory, which is referred to as a. Variables can be classified into two categories. Local variables. These are variables that are within the scope of a program, function, procedure. Global variables. These are variables that are in the scope for the time of the program's execution. They can be retrieved by any part of the program. Variables allow programmers to quickly create a wide range of simple or complex programs which tell the computer to behave in a pre-defined fashion. Basic program structures. People impart logic to computers through programs. Using specific logic structures, a programmer can prepare a computer to make decisions. The most common logic structures are if, then. This logic structure allows the computer to make a decision based on the result of an expression. An example of an expression is my var greater than 0. This expression is true if the value stored in the my var variable is greater than 0. When an if-then structure is encountered, it evaluates the provided expression. If the expression is false, the computer moves on to the next structure, ignoring the contents of the if-then block. If the expression is true, the computer executes the associated action before moving on to the next instruction in the program. Figure 1. For loops, these are used to execute a specific set of instructions a specific number of times, based on an expression. The term loop comes from the fact that the set of instructions is executed repeatedly. While the syntax of for loops varies from language to language, the concept remains the same. A variable acts as a counter inside a range of values identified by a minimum and a maximum. Every time the loop is executed, the counter variable is incremented. When the counter is equal to the defined maximum value, the loop is abandoned and the execution moves on to the next instruction. Figure 2. While loops, these are used to execute a specific set of instructions while an expression is true. Notice that often the instructions inside the loop will eventually make the expression evaluate as false. Figure 3.
সো আমরা যা পড়েছি এখন প্রোগ্রামিং ল্যাঙ্গুয়েজ কনসেপ্টগুলো ক্লিয়ার হব। যেমন compiled programming language turn the computer program into the machine language. Interactive software. System software হবে system software যেমন compiled programming machine language system software known as system software. Python is interactive programming language. Graphical flowchart, step by step algorithm, and will for execute proceed the long and straight condition and proceed with the fixed number and time. This global variable and local variable, only variable in memory. Check this all is correct. অবশ্যই থিওরি পার্টটা প্রপারলি কমপ্লিট করতে হবে। Then expression, identify programming terms. This one সো অবশ্যই আমাদের আইডেন্টিফাই প্রোগ্রামিং টার্মগুলো এরকম হবে। সো ইফ দেন ফর ডু এবং উইল ডু। পাসওয়ার্ড, যদি পাসওয়ার্ড 1 2 3 4 5 তাহলে ট্রু হবে। ফর কাউন্ট 10 ফর। তো এবার আমাদের ফ্লোচার্টগুলো সাজাতে হবে। Flowchart. Flowchart are normally used to diagrammatically illustrate to process flow before a computer program is created. In this lab, you will create a simple flowchart showing the process used to find a predetermined integral value. Basic programming using locally. So,
what is Blockly? Blockly is a visual programming tool created to help beginners understand the concepts of programming. By using a number of block types, Blockly allows a user to create a program without entering any lines of code. This is shown in Figure 1. Blockly implements visual programming by assigning different programming structures to colored blocks. The blocks also contain slots and spaces to allow programmers to enter values required by the structure. Programmers can connect programming structures together by dragging and attaching the appropriate blocks. Programming structures such as conditionals, loops, and variables are all available for use. Creating a new variable in Blockly is a simple matter of dragging the variable block onto the workspace and filling in the value slot. It is also possible to change the contents of a variable as the program is being executed. Figure 2 shows a Blockly variable. Blockly also supports functions similar to the variables. Blockly has specific blocks to represent functions. Also similar to variables, programmers simply select and drag function blocks to the workspace and fill in the required slots. Notice in figures 1 and 2 that the variable block and the print on screen block both have a bevel tab on the bottom and a slot on the top. This means that the two blocks can be snapped together to create a program sequence. Blockly will execute the block on the top first, then move on to the block below it. Other blocks are available such as an if-then block, a while block and a for block. There are also blocks specifically for sensors and actuators. Blockly can be used to translate the block-based code into Python or JavaScript. This is very useful to beginner programmers. Blockly Games. Google provides a series of free and open-source educational games that can help you learn programming. The series is called Blockly Games. To learn more about Blockly Games, or to try it yourself, click here. There are a number of levels to complete to help you get started. Blockly may look like a toy, but it is a great tool to improve your logical thinking skills, which is one of the building blocks of computer programming. Packet Tracer. Blinking an LED using Blockly. Cisco Packet Tracer has incorporated Blockly as one of the programming languages available in its IoT functionality. In this lab you will control the blink rate of an LED using Blockly code.
What is Python?
What is Python? Python is a very popular language that is designed to be easy to read and write. Python's developer community adds value to the language by creating all types of modules and making them available to other programmers. The core philosophy of the language is summarized by the document The Zen of Python. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Readability counts despite the fact Python is designed to be easy. There is still a learning curve. To make it easier to learn Python, a beginner can use Blockly to enhance his or her Python understanding. While different programming languages have different semantics and syntax, they all share the same programming logic. Beginners can use Blockly to easily create a language-independent program. Export it as Python code and use this newly created code to learn about Python syntax, structure and semantics. Figures 1 and 2 show the guessing game program in both Blockly and Python formats. The Python interpreter. Python is an interpreted language. Therefore, an interpreter is required to parse and execute Python code. The Python interpreter understands and executes Python code. Python code can be created in any text editor, and Python interpreters are available for many operating systems. Python developers can create and deploy Python programs in practically any operating system. Third-party tools such as Py2x and PyInstaller can also be used to package the Python source code into an executable file, eliminating the need for the Python interpreter when running Python code. In Linux machines, the Python interpreter is usually installed in USR, bin, Python or USR, bin, Python 3, depending on the available Python versions on the system. With the new Windows Python installer, Python is installed by default into the user's home directory. In older Windows machines, Python is often placed in CPython-XX, where XX is the version of Python. After the Python interpreter has been installed, it operates somewhat like the Linux shell. This means that when called with no arguments, it reads and executes commands interactively. When called with a file name argument or with a file as standard input, it reads and executes a script from that file. To start the interpreter, simply type Python or Python 3 at the shell prompt. Some legacy systems are still running on an older version of Python 2, but many new systems are moving to use the new Python version 3. Python's version is printed on the first line when the interpreter is launched, Figure 1. This course is built on Python 3 code. when the Python interpreter is called with no arguments, and commands are entered via the keyboard, the interpreter is said to be in interactive mode. In this mode, the interpreter waits for commands. The primary prompt is represented by three greater than signs, greater than greater than greater than. Continuation lines are represented by three dots. Continuation is the default secondary prompt. The greater than greater than greater than prompt indicates the interpreter is ready and waiting commands. Continuation lines are needed when entering multi-line code. Figure 2 shows an if-then block written in Python. Another way of using the interpreter is Python C command, arg, which executes the statements in the command. Because Python statements often contain spaces or other characters that are particular to the shell, it is suggested to enclose the entire command between single quotes. Figure 1 is a screenshot of the Python interpreter welcome message. Figure 2 shows an if-then block written in Python. Variables and basic statements in Python. The interpreter receives and executes statements interactively. The interpreter acts as a simple calculator. You can type an expression on it and it will write the value. Expression syntax is straightforward. The operators plus, asterisk and work just as they do in most other languages, for example, Pascal or C. Parentheses can be used for grouping, as shown in Figure 1. Python's interactive mode implements the special variable underscore to hold the result of the last expression issued, as shown in Figure 2. Variables are labeled memory areas that are used to store runtime program data. To assign values to variables in Python, use the equal to smiley face sign. No result is displayed before the next interactive prompt, as shown in Figure 3. Attempts to use a not defined variable, no assigned value, will result in an error, as shown in Figure 4. Strings, defined as a sequence of characters, can also be handled by interactive mode. Use the / character to escape characters. As an example, a string uses double quotes but also needs to use a double quote within the string. If the string is entered as follows, I really need this, Python will get confused and think that the first double quote within the string actually ends the string. If you place a / before the double quotes inside the string as follows, I really need this, the / causes Python to escape or ignore the character that follows. Single quotes or double quotes can be used to wrap strings, as shown in Figure 5. The print statement prints the result of the expression it was given. It differs from just writing the expression you want to write, as we did earlier in the calculator examples, in the way it handles multiple expressions and strings. Strings are printed without quotes, and a space is inserted between items, so you can format things nicely, as shown in Figure 6. Functions are an important part of many programming languages. Functions allow for a block of code to be given a name and reused as needed. Figure 7 defines a function to add two numbers and print the result. Useful functions and data types in Python. Python supports many useful functions and data types. Some of the more important ones are as follows. Range. The range function generates a list of numbers usually used to iterate with for loops. Figure 1 shows examples of the range function. Range stop. This is the number of integers, whole numbers, to generate, starting from 0. Range start, stop, step. This is the starting number of the sequence, the ending number in the sequence, and the difference between each number in the sequence. Tuples. A tuple is a sequence of unchangeable Python objects. Tuples are sequences, separated by parentheses. Figure 2 shows examples of tuples. Lists. Lists are a sequence of changeable Python objects. Lists can be created by putting different comma-separated values between square brackets. Figure 3 shows examples of lists and how they can be updated. Sets. Sets are unordered collections of unique elements. Common uses include membership testing, removing duplicates from a sequence, and computing standard math operations on sets such as intersection, union, difference, and symmetric difference. Figure 4 shows examples of sets. Dictionary. A dictionary is a list of elements that are separated by commas. Each element is a combination of a value and a unique key. Each key is separated from its value by a colon. The entire dictionary is written within braces. Dictionary elements can be accessed, updated, and deleted. There are also many built-in dictionary functions, such as a function that compares elements within different dictionaries and another that provides a count of the total number of elements within a dictionary. Figure 5 shows examples of dictionaries. Programming structures in Python. Similar to other languages, Python implements an if-then structure. If-then blocks can be used to allow the code to make decisions based upon the result of an expression, as shown in Figure 1. The code performs a few tests and prints a message in accordance with the results of the test. Notice that Python also implements two substructures named else and elif. Else allows the programmer to specify instructions to be executed if the expression is false. Short for else if. Elif is used to perform a second test in case the first expression is false and another test is required. There can be 0 or more elifs, and the else part is optional. The for loop in Python iterates the items of any sequence, a list or a string, in the order that they appear in the sequence, as shown in the Figure 2. The while loop executes a block of code if the expression is true. The program shown in Figure 3 uses a while loop to calculate and print an initial subsequence of a Fibonacci series in which each number in the series is the sum of the previous two. The third line contains a multiple assignment operator. The variables a and b get the new values of 0 and 1 in a single statement. The while loop calculates the next term in the Fibonacci series while the condition b less than 10 is true. As in C, Python assumes any non-zero integer value as true and 0 as false. The test used in the figure is a simple comparison. Notice that the body of the loop is indented. Indentation is Python's way of grouping statements. At the interactive prompt, you have to type a tab or spaces for each indented line. More complicated input for Python should be done with a text editor. When a compound statement is entered interactively, it must be followed by a blank line to indicate completion, because the parser cannot guess which line will be the last line. Note that each line within a basic block must be indented by the same amount. Lab. Setting up a virtualized server environment. Virtualization software allows a single physical server to host multiple virtual machines. These machines are isolated from each other and can be saved, copied, and shared. This provides an excellent development and testing environment. In this lab you will set up a virtual development environment and install a virtual machine in preparation for experimentation with Python. Defining prototyping. Prototyping is the process of creating a rudimentary working model of a product or system. For prototyping in the IoT, it helps to have design skills, electrical skills, physical, mechanical skills, work with your hands to put things together, programming skills, and to understand how TCP/IP works. But you do not need to be an expert in any of these areas. In fact, prototyping helps you to refine these skills. Because the IoT is still developing, there are still unknown tasks to discover. This is a great time to invent something that is part of the IoT. Because the IoT combines people, process, data, and things, there is no end to the inventions that the IoT can help create and then incorporate. For news and ideas that are already being talked about in the IoT, click here. How to prototype. How do you prototype? There are a few ways to get started. A team at Google used the rapid prototyping method to create the Google Glass. Click here. View a TED Talk about this process. Of course, Google has a large number of resources to pay for the people and materials that go into prototyping. Most of us need some financial help to get our ideas out of our heads and into a prototype. For us, there is crowdfunding. Kickstarter, Indiegogo, and Crowdfunder are just 3 of the many online crowdfunding programs. Click here to view the Pebble Watch Kickstarter video. This online video was used to generate donations to help this group of inventors create the Pebble Watch. What IoT invention will you create? The image is of a child using a tool on a circuit board. Physical materials. A good place to start is, of course, the Internet. People have exchanged ideas for ages, but the Internet allows for idea exchanges on a whole new level. People who have never physically met can now collaborate and work together. There are several websites you can visit to connect with other makers. Maker Media is a global platform for connecting makers with each other to exchange projects and ideas. The platform also provides a place where makers can find and buy products for their projects. For more information, go to Makezine at http://makezine.com. It is helpful to have practical skills when working with certain materials. For example, wood and metal are common prototyping materials. But they may be too difficult for a beginner to use. You might be surprised with what you can do with plastic, clay, paper, and wires. Search Google for more information or ideas on how to work with the different prototyping materials. LEGO Mindstorms has a large community of contributors and fans. With LEGO Mindstorms, you can create LEGO robots and control them using an application. The kits come with everything you need to make it work. Go to LEGO Mindstorms at http://mindstorms.lego.com. Meccano, or erector set, is a model construction system that consists of reusable metal strips, plates, angle girders, wheels, axles, and gears, with nuts and bolts to connect the pieces. It lets you build working prototypes and mechanical devices. Go to Erector Set at www.erector.us. 3D printing is the process of making a solid object based on a 3D model computer file. A machine, called a 3D printer, is connected to the computer. A number of companies now build and sell 3D printers. Go to MakerBot at https://www.makerbot.com. Electronic toolkits. Computer programs cannot run without a computer. While you can create programs for almost any computer, some platforms are designed for the beginner. Below you will find some of the most popular platforms. Arduino is an open-source physical computing platform based on a simple microcontroller board, and a development environment for writing software for the board. You can develop interactive objects that take input from a variety of switches or sensors to control lights, motors, and other physical objects. Go to Arduino at http://arduino.cc. While the Arduino is not suitable for use as a computer, its low power requirement makes it capable of controlling other devices efficiently. The Raspberry Pi is a low-cost, credit card-sized computer that plugs into a computer monitor or TV. You operate it using a standard keyboard and mouse. It is capable of doing everything a computer can do, from browsing the internet and playing high-definition video, to making spreadsheets, word processing, and playing games. Go to Raspberry Pi at http://www.raspberrypi.org. The BeagleBone is very similar to the Raspberry Pi in size, power requirements, and application. The BeagleBone has more processing power than the Raspberry Pi. Therefore, it is a better choice for applications with higher processing requirements. Go to BeagleBone at http://beagleboard.org. Programming resources. Programming is critical to the IoT. Creating custom code is very useful when developing an IoT solution. You have already learned about Blockly and Python. There are many other free resources that can help you develop your programming skills. The MIT OpenCourseware, OCW, is a web-based publication of almost all MIT course content. Open and available to the world, OCW is a great place to get familiar with computer programming for free. OCW programming-related courses can be found at http://ocw.mit.edu/courses/intro-programming. Khan Academy is a non-profit educational website created in 2006 to provide a free, world-class education for anyone, anywhere. The lectures related to computer programming can be found at https://www.khanacademy.org/computing/cs. Code Academy is another excellent resource. It relies on interactivity to help people learn how to write computer programs. You can find them at http://www.codeacademy.com. Community Inventor and Entrepreneurship Workshops. So, perhaps you have just created something really great. What now? There are a number of places where you can get help exposing your idea or prototype to others. Investigate what is available in your community. Check with your local government, schools, and Chamber of Commerce for information about workshops, classes, and expert advice. The Internet has many resources to help your idea get exposure. A good example is Quirky. Quirky allows users to share their ideas. When an idea is submitted, other Quirky users can vote and choose whether or not they want to support your idea. If an idea is good, it may become a real product. You can learn more about Quirky at https://quirky.com/about-quirky/. Optional lab. Setting up Place app with the Raspberry Pi. Cisco Prototyping Lab is a set of hardware and software components that enable the rapid prototyping and modeling of various IoT digitization and data analytics solutions. The hardware components are part of the Prototyping Lab Kit, Place Kit. The Place Kit is based on OpenHW prototyping boards such as Raspberry Pi and Arduino. The Place Kit includes additional sensors, actuators, and electronic components. The Place Kit can be used to build sophisticated prototypes of end-to-end IoT systems that can sense and actuate the real physical world, analyze and process the data, and connect to network and cloud systems. The primary software component of the Prototyping Lab is the Prototyping Lab app, Place app. The Place app together with the Place Kit enable IoT digitization and data analytics learning and rapid prototyping. Place app provides a web-based environment to access the software and hardware resources of the Raspberry Pi, using Jupyter notebooks. With Place app you can access existing IoT labs or write your own new applications directly on the board, execute them, and monitor the output with various visualizations. In this lab you will download a Raspberry Pi OS and install it on a micro SD card. After installing the micro SD card, the Raspberry Pi and the Arduino connected to the Raspberry Pi can be controlled from the Place app interface. This lab provides basic guidelines for the initial configuration of the Raspberry Pi board with a Place app environment. Lab. Setting up Place app with the Raspberry Pi. Place app launcher for Windows, Place app launcher for Mac, Place app image for Introduction to IoT 2.0. Click here to view a video walkthrough of this lab. Click here to read a transcript of this video. Optional lab. Blinking an LED using Raspberry Pi and Place app. In this lab, you will use a sample Place app notebook to interact with an LED as part of a simple circuit. You will build a simple circuit on a breadboard with a resistor and an LED. You will then use the LED blink program to control the blinking rate of the LED. Note: in order to view the Blockly code in the Jupyter notebooks, please use the Google Chrome web browser. Note: this Jupyter notebook can be found by starting Place app and navigating to the Introduction to IoT folder under Course Materials. Lab: blinking an LED using Raspberry Pi and Place app. Lab preview. Click here to view a video walkthrough of this lab. Click here to read a transcript of this video.